Hello everyone, you are welcome to solve this nice Math Olympiad problem, which is x plus y. This is equal to 4. Let's call this equation 1. And x to power 5 plus y to power 5. This is equal to 464. Let's call this equation 2. What is the value of x and what is the value of y? Now let's provide solution here. It's a comprehensive solution. Now from equation 1, we have x plus y. This is equal to 4. So the first thing, let's square both sides from here. So here we have x plus y squared. This is in the form of a plus b squared, which we can express as a squared plus b squared plus 2 times a times b. Applying this algebraic identity, then here we have x squared plus y squared plus 2xy. This is equal to 4 squared, which is equal to 16. So therefore, we have that x squared plus y squared. Let's take 2xy on the right hand side. So we have 16, subtract 2xy. So let's call this equation 3. Now again, from now the second step from here, from equation 1 again, which is x plus y, let's raise it to power 3, and this we do on both sides. So this implies here we have that this is x to power 3 plus 3x squared multiplied by y, then plus 3xy squared, then plus y to power 3. So this is equal to 4 raised to power 3, that is 4 cubed, which is 64. The next phase here, we have x to power 3 plus y to power 3, then plus 3x squared multiplied by y plus 3xy squared. This is equal to 64. But we can factor out here, we can factor out xy. So we have x to power 3 plus y to power 3, then plus, here we have 3xy. So this implies that we can factor out x plus y. This is equal to 64. The next step is that x plus y from equation 1, that is from equation 1, this is equal to 4. So let's substitute this. So you have x to power 3 plus y to power 3 plus 3xy times 4. This is equal to 64. So here we have x to power 3 plus y to power 3, then plus 3 times 4 here. This is 12xy. This is equal to 64. So let's take 12xy on the right hand side. So you have x to power 3 plus y to power 3. This is equal to 64. Subtract 12xy. And let's call this equation 4. Now, the third step from here, the next step here is to multiply equation 3 and 4. Now, equation 3 here is x squared plus y squared. This is 16 minus 2xy. And we have equation 4 here. So let's multiply the two of them. So equation 3 times equation 4. So we have x squared plus y squared multiplied by x to power 3 plus y to power 3. This is equal to 16 minus 2xy multiplied by 64, subtract 12xy. So this implies that from here, we have x to power 2 times x to power 3 plus y to power 3, then plus y to power 2 times x to power 3 plus y to power 3. This is equal to 16 minus 2xy times 64 minus 12xy. Now the next step is that x squared times x to the power 3. So this is the same. We have x to the power 2 times x to the power 3, then plus x to the power 2 multiplied by y to the power 3, then plus y to the power 2 times x to the power 3, then plus y to the power 2 times y to the power 3. This is equal to 16 minus 2xy, then multiplied by 64 minus 12xy. So here, x raised to the power 2 times x to the power 3, this is x to the power 5, plus x to the power 2 times y to the power 3, this is x to the power 2 times y to the power 3, then plus y to the power 2 times x to the power 3, then plus here y to the power 2 times y to the power 3, this is y to the power 5. This is equal to 16 minus 2xy times 64 minus 12xy. Now, the next step from here, we have x to the power 5 plus y to the power 5. Close the bracket from here. Then we have plus, we can factor out x squared and y squared, so that now here we have x plus y, that is x plus y. This is equal to 16 minus 2xy multiplied by 64 minus 12xy. So we have that x to the power 5 plus y to the power 5. This is what we have in equation 2. Equation 2 here. X to the power 5 plus y to the power 5. This is equal to 464. So let's substitute 464. So we have 464 plus x to the power 2 multiplied by y to the power 2. Then x plus y is what we have in equation 1. X plus y is equal to 4. So let's substitute 4. So here we have 4. Then this is equal to 16 minus 2xy times 64 minus 12xy. Now, the next step from here, we have 464 plus, here we have 4x squared, y squared. This is equal to, now this is 16 minus 2xy. We have 64 minus 12y, so we can factor. So from 64 minus 12xy, we can factor out 4. Then now we multiply here by, this is the same thing as 16 minus 3xy. On the left hand side here, we have 464 plus 4x squared y squared. So 4 is common here. We can factor out 4. Then you see 464 divided by 4. This is 116 plus x squared y squared. This is equal to 16 minus 2xy multiplied by 4. We need to factor 4 here. So we have 16 minus 3xy. So we have 4. Let's simplify here. 4 and 4 simplifies, so that we have 116 plus x squared y squared. This is equal to 16 minus 2xy multiplied by 16 minus 3xy. The next step is to say, let xy be equal to a. Substituting the value of a, this implies that here we have, this is the same thing as 116 plus, now this is x squared plus y squared, this is a squared which is equal to, here we have 16, subtract 2 times a, then here we have 16 minus 3a. So here we have 116 plus a squared. This is equal to, this is 16 multiplied by 16 minus 3a minus 2a multiplied by 16 minus 3a. See, we have 116 plus a squared. This is equal to 16 times 16. This is 256. Subtract 16 times 3a. This is 48a. Then subtract 16 times 2a. This is 32a. Then minus 2a times minus 3a. This is plus 6a squared. From here, we have 116 plus a squared. Let's take 116 plus a squared on the right-hand side. So here we have 256. Subtract 48a minus 32a plus 6a squared. Subtract 116, then minus a squared. This is actually equal to 0. Now, this implies here we have 256 minus 116, and this is actually equal to 140. This is 140. Then minus 48a minus 32, we have minus 80a, then plus 6a squared minus a squared, this is 5a squared. So this is equal to 0. Now, let's rearrange this equation as 5a squared minus 80a plus 140. This is equal to 0. Now, from this equation, we can factor out 5, so that here this is a squared minus 16a, then plus, here we have 28. This is equal to 0. Let's divide both signs by 5, so that here we have a squared minus 16a plus that is 28. This is equal to 0. So this is a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. From this quadratic equation, we have a equal to 1, b equal to minus 16, and c equal to 28. So we can solve this quadratic equation by applying the factorization method, where we have the product as 28. The sum here is equal to minus 16. This is minus 16a. So these factors, these two factors, we have minus 14a, we have minus 2a. Now, in this case, if you see minus 14 times minus 2, we'll have 28. And minus, in this case, minus 16a, this is the same thing as minus 14a plus minus 2a. So that the quadratic equation now becomes a squared minus 14a subtract 2a, then plus 28. This is equal to 0. So from here, we can factor out a, so that here we have a minus 14. Then subtract a, we have 2. That is 2 into the parentheses. 2 is common here. We have a minus 14. This is equal to 0. So we have a minus 2, and we have a minus 14. This is equal to 0. So this implies that we have two parts here. The first part is a minus 2. This is equal to 0. The second part here is a minus 14. This is equal to 0. We have the first value of a, that is a1, is equal to 2. And a2 from here, this is equal to 14. But now, if you recall, we are saying that let x, y be equal to a. So starting with a1, we have that x, y is equal to 2. And the other side here, a2, we have that x, y is equal to 14. Now we have xy here is equal to 2 and xy is equal to 14. Let's start with xy is equal to 2. So we have xy is equal to 2. From equation 1, which is x plus y, this is equal to 4. And given that x minus y squared, this can be expressed as x plus y squared subtract 4xy. From here, from what we have here, x plus y here is the same thing as 4, and we have xy, which is equal to 2. So this implies that x minus y squared, this is equal to 4 squared, subtract 4 times xy, which in this case is equal to 2. Okay? So this implies x minus y squared, this is equal to 16, minus this is equal to 8. So x minus y squared, this is equal to 16 minus 8, which is 8. So for x minus y, we introduce a square root sign on both sides, so that here we have plus or minus the square root of 8. So let's simplify here. So we have x minus y, this is equal to plus or minus the square root of 8. We can express 8 as 4 times 2. So this implies that x minus y, this is equal to plus or minus the square root of 4, this is 2, then square root of 2. So we have that x minus y is plus or minus 2 square root of 2. Now, given that equation 1 is x plus y is equal to 4, now that we have x minus y, this is equal to plus or minus 2 square root of 2. So these are two systems of ring equations. So the next step is to add these two systems of ring equations. So x plus x, this is 2x. Then we have y plus minus y, this simplifies. Then we'll have this equal to 4 plus or minus 2 square root of 2. But now here we have that 2 is common here. We can factor out 2. So here we have 2 plus or minus square root of 2. Let's divide both sides here by 2 so that x is equal to 2 plus or minus square root of 2. Now we have that x is equal to 2 plus or minus square root of 2. So this implies that x1 is equal to 2 plus square root of 2, and x2 here is equal to 2 minus square root of 2. So this implies that from here, from equation 1, which is x plus y, this is equal to 4, we can solve for the value of y. So this implies that y1, this is equal to 4 minus x1, which is 2, plus square root of 2. So here we have y1 equal to 4 minus 2, then minus times plus square root of 2, this is minus square root of 2. So this implies that y1 is equal to 4 minus 2, this is 2, subtract square root of 2. So we have x1, x1. So we have x1, y1, which is equal to 2 plus square root of 2, and we have 2 minus square root of 2. This is the first set of solution here. This is the first set of solution. If you check here, we have x2 is 2 minus square root of 2. Again, by referring equation 1, which is x plus y, this is equal to 4, we can solve for y2. y2 is equal to 4 minus x2. So in this case, we have 4 subtract 2 minus square root of 2. So this is the same thing as 4 minus 2. This is 2. Minus times minus square root of 2. This is plus square root of 2. So this implies that x2, comma y2, this is equal to 2 minus square root of 2, comma 2 plus square root of 2. So this is the second set of solutions. Now these are the first two sets of solutions when x, y is equal to 2. So let's proceed to x, y. Let's proceed that when xy is equal to 14, let's solve for the values of x and y. Now again, if you recall that equation 1 is x plus y, this is equal to 4. And given that x minus y squared, this is equal to x plus y squared, subtract 4 times xy, we have that x plus y is equal to 4. We have that xy is 14. So let's substitute here. X minus y squared. This is equal to 4 squared minus 4 times 14. So here we have 16. Subtract 14 times 4. This is 56. So that now this is 16 minus 56. This is minus 40. So x minus y squared, this is equal to minus 40. To solve for x minus y here, we introduce a square root on both sides. So here we have plus or minus the square root of minus 40. So this implies that x minus y, this is equal to plus or minus, and we can express the square root of minus 40 as 4 times 10 times minus 1. So this implies that x minus y, this is equal to plus or minus the square root of 4, this is 2, square root of minus 1, this is I, then square root of 10. Now, from what we have here, we have that from equation 1, which is x plus y, this is equal to 4. And given that here, we have x minus y, this is equal to plus or minus 2i square root of 10. So these are two systems of linear equations. Let's add these two systems of linear equations. So that now here, this is x plus x, this is 2x. Y plus minus y, this simplifies, and this is equal to 4 plus or minus 2i square root of 10. We can factor out 2 here, so we have 2x is equal to 2 into the parentheses 2 plus or minus I square root of 10. So let's divide both sides here by 2, so that now x is equal to 2 plus or minus I square root of 10. So again, we have two values of x here. I can call this x3. This is equal to 2 plus I square root of 10. And we have that x4 is equal to 2 subtract I square root of 10. So let's solve for the corresponding values of y3 and y4. Now we have x3. Now here we have x3 is 2 plus I square root of 10. And x4 is 2 minus I square root of 10. Let's solve for the corresponding values of y3 here. Now, given that from equation 1, which is x plus y, this is equal to 4, we can solve for the value of y given that we have x. So y3 is equal to 4, subtract 2 plus I square root of 10. So this implies that y3, this is equal to 4 minus 2, this is 2, minus times plus I square root of 10. This is minus I square root of 10. So this implies here x3, comma, y3, this is equal to 2 plus I square root of 10, and y3 is 2 minus I square root of 10. This is the third set of solution. Now, we have that x4 here is 2 minus I square root of 10, and given that x plus y, this is equal to 4, we can solve for y4, which is equal to, this is equal to 4, subtract 2 minus I square root of 10. So this implies here we have that y4 is equal to 4 minus 2. This is 2. Minus times minus I square root of 10. This becomes I square root of 10. This is plus I square root of 10. So we have x4 and we have y4. So this implies that we have the last set of solution as x4, comma, y4, and this is equal to 2 minus I square root of 10, and then we have 2 plus I square root of 10. So these are all set of solutions that we have. We have 4 set of solutions, that is x1, x1, y1, and x2, y2, and we have here x3, y3, and x4, y4. These are set of all the solutions that we have for this algebra problem. So kindly follow the steps, like this video, and subscribe. Kindly like and subscribe. See you in the next video.